Y ahora vamos a tener una presentación de Guru, que es de Waku. Vamos a charlar sobre comunicación web3 intransigente en gran escala con Waku. Y Guru es un defensor de la privacidad de datos y vencedor de más de 50 hackathons. Parte de la charla va a ser en inglés, pero también vamos a tener algunas cosas en español. Entonces, Guru, sea muy bienvenido. Waku también es uno de los sponsors del evento, un gran proyecto que está ayudando a hacer todo esto posible.
Cool. So, hey everyone, I'm Guru. I work as a co-contributor and a developer relations engineer at Waku. So, you can find me on the socials. So, talking about the problem, Web2 communications do not preserve your privacy. So, every time you make an interaction in your Instagram or your Twitter or any kind of Web2 application, your privacy is being exploited. There's a lot more information getting leaked than you think, and your social graph and your private data can be exploited by these centralized gatekeepers. Your messages are linked to your IP addresses, so every time you message using a Web2 application or interact with something using a Web2 application, your IP address is being leaked, and your IP address can expose a lot more information than you think. For example, it can expose the sender and receiver details, the locations, and also the private metadata that is associated with these messages. So these information can facilitate censorship and large-scale surveillance attacks, which is happening in a lot of countries around the world, and this ultimately hinders the freedom of speech. So this is not just a problem with chat, but it exists with a lot of other use cases as well. Like when you see gaming, you can see that a lot of games store your important and crucial data, and it can be exploited in a lot of ways for advertising and a lot of things. And you have other use cases like marketplaces, location sharing, IoT networks, state channels. So all these kind of communications are putting you into risk of getting exploited. So going ahead, we wanted to solve this problem, and that's why we are building Waku. Waku is a family of robust censorship-resistant communication protocols, which are designed to enable privacy-focused Web3 applications. And we have 6 main ethos. The first one is privacy. We wanted to make sure all the messages stored in the Waku network are privacy focused. And it's also censorship resistant, which means that no centralized stakeholder or centralized gatekeeper can censor your content that is being transmitted using Waku. It's modular and adaptive. Adaptive over here means that it can run in your mobile phone, to a cluster, to a VPS server, or anywhere that can run a Docker container. And it's also securely scalable. We have our own scalability mechanisms, which I'll be explaining in the upcoming slides. And most importantly, Waku is rate limited. So the first misconception that I want to solve here is that Waku is not a chat messaging protocol, but Waku is a generalized censorship-resistant messaging protocol. This means that you can use Waku in a lot of other fields except traditional chats. So please don't build chat applications with Waku because we've got a lot of them already. So talking about some quick history, we started in 2013 with the Ethereum white paper, which mentioned Whisper as the communications layer of Web3 and Swarm as the storage layer. So this was called the Ethereum Trinity. And over the years, there was not much of development with Whisper and Swarm. And most of these technologies have been forgotten over the period of times. In 2020, Waku V1 replaced Whisper in the status app, and today Waku is evolving as the standard for Web3 communications. So in a nutshell, we have 2 segments in Waku. The first one is the Waku protocols, and the second set of segment is Waku network. So going with the Waku protocols, we have different implementations in different platforms. We have a TypeScript implementation called JS Waku, and NWaku, which is a NIM implementation, Go Waku in Golang. You also have bindings for Rust and C, and some React hooks to make your React development journey simpler. Today's workshop will be covering about the 3 main protocols, light push, filter, and store, which come under the light push protocol section. And we have more protocols as well, so you can learn more about these protocols in the documentation. But going ahead, we'll be looking at the purpose of each of these protocols. The first one, light push, is used for sending a message into a content topic. Filter is for subscribing messages from a content topic. And store is for temporary storage, for persisting your messages for a short period of time. So these are the 3 protocols that you should be knowing to build something with Waku. And Waku works on a content topic based architecture. I'm sure you must be confused with what content topics are, but we have different content topics within the Waku network. For example, here you have topic A, topic B, and topic C. So there can be multiple nodes listening to multiple topics. So there's a mobile phone connected to topic A, which is talking to a cluster. So it's highly interoperable, and Waku's design is made in a highly interoperable way. So we follow a standard for naming each and every content topic. So this is the template that we use for naming a content topic. And an example for this would be Super Crypto is the name of the app, and number 1 is the version over here, and notification is the category of the messages that are getting stored in a particular topic, and Proto is the encryption type that you're going to use, like the encoding type that you're going to use. So brushing it up, coming back, we have light push for sending a message into a content topic, and for receiving or subscribing to messages you use filter, and finally store is used for persistence. So these are the 3 main protocols that you'll be looking at, and this is how a typical Waku message object should look like. You have the content topic, the payload, meta, which usually carries the meta attributes, and timestamp, which mentions the time in which a message was sent, and also finally ephemeral. So ephemeral can be either true or false. If you want the message to be stored in the network, it should be true, and if you don't want it to be stored, it can be false. So ephemeral basically rules out the store protocol if you set it to false. So coming to the second segment, the Waku network, we have different implementations here as well. The first one is NWaku, which is the NIM implementation. It's being used widely across a lot of projects which are in production right now, a lot of well-known web3 projects that I'll be showcasing. And we also have a Docker compose command and a Docker container command, and also a dApp node where you can spin up a node in a matter of few clicks. So talking about adaptability, Waku can run from a device as small as a mobile phone with less resources, and it can go to a cluster which has high resource environments. So we have different implementations that can cater to each of these resource restricted environments. And Waku network is quite easy to, you can easily spin up a Waku node by a matter of few commands. So we are also having a giveaway. We are doing a giveaway of 20 Waku flasks for the first 20 people who try to run a node using this instruction set. So you can scan it out and just type in a few commands on your terminal and you'll be having a Waku node running. So yeah. And if you want to dig more about the Waku node and the architecture of Waku and Waku nodes, you can go to this specific research article. So yeah, this pretty much has all things about Waku nodes. So this is a quick demonstration of how fast Waku is. Starts from India, goes to Singapore, and then to Los Angeles, to San Francisco and to New York. So this is the speed or the pace in which a 2 KB size message object is being transmitted across the Waku nodes. So you can see the console logs over here, but we are trying to build Waku as performant as possible without compromising on things like scalability and level of decentralization. I also have some important resources that can be useful for hackers over here to start building with Waku. The first one is documentation, which pretty much has everything about Waku. And the second one is the idea board, which has around 50 or 60 ideas that you can use for building with Waku. And you're not restricted to these ideas, but they are just a place for inspiration. So finally, you also have the awesome Waku repository where we have projects from the last 4 hackathons that we did last year in Rome, India, and also in a couple of other places. So you can find 81 projects over there, the submission videos and stuff. And I also wanted to give a few project spotlights from our ecosystem. So the first slide is about the enterprise level projects, where we have projects like XMTP, the Graph, Railgun, and Status built on top of us. So we are an underlying infra for all these projects. And coming to more of an indie builds or more like grassroots level projects, we have some hackathon projects from the previous hackathons. The first one is called Block IoT, which was the winner of a previous hackathon, where they implemented an IoT system on top of Waku. So your home can be automated with Waku. All the communications can happen through Waku. And the second one is Becamose, which is a privacy preserving wallet-to-wallet location sharing app. So you can share your location without interference from centralized stakeholders, like the mobile phones that you use usually know your location every time you make a move. So that can happen without having a centralized stakeholder with Becamose. And someone also built a WWE battle card game with Waku. These are the kind of ideas that we're really looking forward to. We want people to build crazy stuff, games, and fun stuff on top of Waku, not just something very serious and philosophical, but also something very fun. So the recent buzz was about a project called Mr. Fox, who tried to build a privacy layer on top of AI. So when you check out LLM models, they usually log your identity with the prompts that you give. So they try to decouple the identity from the prompts. So this was a pretty exciting project as well. Coming to the most interesting part, the bounties. We have bounties worth $2,500 US, and the first prize would be $1,500 for the winner for the best implementation of Waku, and the second prize would be $500 for the runner. And the best part about the Waku bounties, at least for me, would be the quadratic pool prize. Everyone gets something out of the pool prize if you build something with Waku. We have a total of $1,000 split between all the teams. So you'll be definitely getting a piece of it if you build something successfully with Waku. And the biggest note that I want to make here is please don't build traditional chat apps, because we already have a lot of them. So all chat apps don't qualify for the Waku bounties. So yeah, finally, if you wish to learn more about Waku, make sure to check out our documentation. And we also have our Discord where you can join and ask questions in our community. We have a lot of Spanish speakers in our team. They're not here in person, but then they're available in Discord for support. And after this, I just wanted to give a quick demonstration, some live coding, where I show you how to send, receive, and store a message with Waku. So I hope at least a few of you know to use Next.js. I'm sure you've been using a lot with React. I met a lot of React folks here, but Next.js is very much similar to React. So I'll be showing an example app that pretty much sends, receives, and stores a message. So yeah, the first step that you'll have to do, let's just go through the docs. So the first step that you'll have to do is to install Waku in your project. For this, you can find the documentation here in JavaScript Waku SDK, and go over here and you can So you can find the commands over here to install Waku as a dependency in your project. So just hit npm install @waku/SDK, which is our JS Waku SDK, and also install protobuf, which is a templating library for your messages. So these are the two main dependencies that you will be requiring. And after that, you'll be having a lot of guides over here. We'll be replicating the same stuff from the guides right now. So once you're done installing these two things, you can go to your code editor and you can basically make all the imports. I'll be explaining each of these imports one by one. But the first step in our process is to set up a Waku node. So for setting up a Waku node, you should be importing something called create light node, and this is all the code that you require for creating a light node instance. So basically you say const node is equal to create light node, and you set default bootstrap to true. So default bootstrap, when it is set to true, the light node tends to get connected to the bootstrap set of fleets that we've already set it up. So it's super fast, especially for development purposes. But you can set it to false, and you can have your own set of fleets for your network as well. But for the sake of this tutorial, we'll be going ahead with true and hit node.start, and this should make console log you a message saying node is started. So let's try to check it out. So when I hit reload over here, you can see a lot of errors getting popped up over here. Make sure, just don't mind the errors, because that's the proof that Waku is trying to connect to a lot of nodes. The internet is pretty slow here, so give me a moment. Oh yeah, so you can see that node is started. And all these GET requests that go out are the proof for Waku trying to connect to different nodes in the network. So once your node is set up, you'll be getting a message called node started, which basically happened because of this set of code. So after that, the step 2 is to create a peer discovery process. So for this, you can use the wait for remote peer function. And once the peers are connected to your node, you'll be finding a message in your console called remote peers connected. That's probably because of the internet, but then you should be getting it once you connect to a better network. Yeah, I can do it all finally. So the next step is to choose your content topic. So the content topic should follow the nomenclature that I mentioned earlier, like it should follow the template that we just saw earlier in the slides. So after that, you can create encoders and decoders. So Waku does not force you to use any specific encoder or decoder, but you are flexible to use your own encoders and decoders. But we also have some preset encoders within our library. You can pretty much encode and decode streams of messages by just using these lines of code. You can use create encoder and pass in your content topic along with your ephemeral to true if you want to create your encoder. And the decoder can be as simple as create decoder and you pass in the content topic. So this is all the code that is needed for creating an encoder and decoder. After that, you'll be going to the chat message section where you template your message object. So for this, we just have a timestamp, a sender, and a message. So timestamp is a event 64 and a sender and a message is a string. So you can basically template your message object with protobuf, which is the library that we installed earlier. And after that, you can simply create chat message.create. Chat message is the object over here. So you can press chat message.create and then create a new chat message object. And you can simply push the chat message object with the light push.send command. So with this, it should pretty much send, store, and also receive the messages. So yeah, I think we can go ahead and try it out now with a different Wi-Fi. So node is started. It should take a few moments to get connected to peers, but yeah, if your internet works well, then it should be fine. The bootstrap nodes are usually fast, like they always work pretty well. Cool. So when that happens, let's go to the idea board. So this basically has some use cases with Waku. Oh, I think the internet is totally out. Do you mind sharing your Wi-Fi? Got it.
Yeah, it's not working, so I'm connected. No, workshop, okay.
Usually is the ATA workshop and password workshop.
I don't see workshop.
Okay.
Cool. So going through the idea board, you can build a voting or polling app with Waku. We also have a Spanish tutorial for doing this. You can find it over here. So it's basically a Spanish article which demonstrates the step-by-step process of building a polling app with Waku. So check this out. You can find the link in the resources section of Waku. And you can also find other ideas which was recently updated. So we are really looking forward to see some two-factor authentication built on top of Waku, and also some censorship-resistant GitHub. Recently, the GitHub's co-founders, GitHub actually got censored by GitHub itself. So to avoid all these funny happenings in the future, it's important to build censorship-resistant infrastructure. So that's why we want someone to build a decentralized and censorship-resistant GitHub. And yeah, you have a lot of other ideas. You can know more about the ideas by just clicking them. But yeah, this is the whole idea of the idea board. And yeah, right now you can see that the node was started, and the remote peers were connected, and then the message was sent. And the message object, basically you can retrieve the message object and put it into a variable to showcase it accordingly. But this is the whole idea of Waku. The simplest implementation took 68 lines of code. So you can implement a very basic CRUD application with Waku in 60 lines of code. But the novelty and innovation is going to be in the use case, how you're going to use Waku, because you can, generally you can send phone numbers and emails on Waku, but it should not happen. That's the whole point of building a privacy-preserving infrastructure. So yeah, I think that's it for the workshop. But if you have any questions, if you have any use cases that you want to discuss, I also have my Spanish-speaking friend over here who can help me out. So do you have any questions? Sure.
What can you say about benchmarks? How does it behave on the scale? And what kind of am I able to send places?
Got it. So we don't have predefined, some benchmark scores that we can guarantee, but then we can comment about the latency in our network and all of those things. So I can show you something that we use internally for measuring this. It's called metrics.waku.org, where we have some network metrics. Right now we just have 2 network metrics. This is the average ping response between nodes. So it's in MS, so it's like 43 MS is the average response right now. But this depends on a lot of other factors, but we are trying to minimize this even to a great extent. But yeah, this is the only published benchmark that we have right now. But if Gabriel wants to comment something, yeah, so that's it for now.
Okay, and what about the web recovery? How can you recover this data guarantee that a message is delivered?
Sorry, can you repeat it again?
How can I guarantee that a message is delivered? How can I know that a message is delivered?
Yeah, so Gabriel, do you want to?
Mejor en español, ¿no?
Ya.
Bueno,
O sea.
digo, que en realidad no tenemos garantía 100%, o sea, no se puede tener garantía 100% en una red descentralizada que el mensaje llegue a todos los nodos, pero en la práctica siempre llega, pero no se puede garantizar teóricamente en este tipo de red.
Ok, ¿y cuáles son las estrategias de entrega? Que puedo personalizar la estrategia de entrega como un FIFO o priority queues, algo así?
No entendí el problema.
O sea, cuando envío un mensaje, puedo definir, can I define priorities on the messages?
Ok, entiendo. No, no se pueden definir prioridades, los mensajes son como van llegando los nodos,
Okay.
no define un callback o qué hacer cuando te llega un mensaje, y sí, pero todo depende de cómo te lleguen. No se puede dar más prioridad a un mensaje que otro.
Okay. And what is the authentication based on? How do I know that I am the only one able to send a message on a topic, for example?
Ok. Si uno quiere, o sea, para garantizar que vos sos el que mandase cierto mensaje, para eso uno tiene que agregar una capa de encripción arriba. Waku como protocolo es lo más básico de infra que hay y uno puede encima de eso hacer lo que quiera, pero si uno quiere garantizar que cierta persona, o sea, que nadie más puede mandar un mensaje a un topic, entonces uno le debería agregar una capa de encripción.
Okay, thank you.
¿Alguna otra pregunta? Sí, y la última cosa que queremos resaltar es que Waku no es solo para chats, es cualquier tipo de comunicación entre computadoras. No es una aplicación para chats y no está hecho específicamente para chats. Entonces eso queremos resaltarlo porque en el hackathon tenemos premios y queremos ver usos diferentes a chats, y esos son los que buscamos recompensar en específico. Entonces eso es para volver a aclarar que Waku es como cualquier tipo de comunicación y no es solo chat entre dos personas.
Perfect. I think that's it from us. So yeah, come visit our booth for some swags, and if you have any questions, we'll be available at the booth for any kind of support. Thank you. Gracias.